wasn't that a fantastic keynote? Radia came to the University of North Carolina School of Computer Science several years ago, and I was so excited to hear her speak. I definitely fangirled a little bit. In that speech, she said that her version of the OSI reference model has a few changes. Not to worry, the physical, data link, network, and transport layers are all intact, but anything above layer 5 has been relabeled as boring. Let's hope I venture no higher than layer 4 today. Unless I do the wrong thing. You got it? My name is Adair Thaxton, and I am a network engineer's worst enemy, a security engineer who used to have a CCNA. This talk is pre-recorded, but I've asked one of my coworkers to hang out and chat and tag team questions and answers with me during the NOG itself. Now, I wanted to give you guys a bit of a fair warning. In this presentation, I'm going to be using the F word. If you have small children or sensitive ears, I just want you to be aware of that. Of course, this is nanog, so the F word in question is firewall. I just didn't want to scare anybody when I said that. This will not be the last Sesame Street creature you see. You're welcome. I work for Internet 2, which is probably one of the fastest networks that some of you have never heard of. When I explain Internet 2 to non-network people, I use the illusion of a toll highway for municipalities, researchers, and students across the country. We connect 46 regional and state education networks, 59 government agencies, and more than 300 universities. Through our state and regional education networks, more than 65,000 K-12 schools are connected to Internet 2. Additionally, we are working with the Minority-Serving Cyberinfrastructure Consortium on a $3 million NSF grant to address the cyber infrastructure needs of more than 700 historically Black colleges and universities and tribal colleges and universities. This is our network backbone map. I did take this snapshot at 11:45 a.m. on a school day because I wanted to try to make it look good. We peer in all the usual places within the United States, and 2020 really made us take a look at our peerings with home ISPs. Science and scientists don't stop researching and applying for grants just because they're working from home. We needed to make some adjustments to allow better connectivity with home ISPs for those people while they're working at home. We also interconnect with more than 65 networks globally, reaching 100 countries. Additionally, we increasingly provide the software and tools that enable users and operators to interact with commercial cloud, big science projects, and other at-scale or large-scale collaborations. I said new network, so let's get into that. We began collecting user requirements for our next generation infrastructure network in 2016. After multiple information gathering sessions with our community, the RFP was issued later that year, and a vendor was chosen in fall of 2020. Our next generation network includes new features, primarily driven by software, automation, and systems virtualization to allow the infrastructure to be more readily integrated into the broader enterprise, campus, regional, and cloud environment around us. Planning for the secure management network, on the other hand, began in 2017, but was paused because, well, I wasn't there at the time, but when that mean old kid blew up our beautiful Death Star, it kind of set us back. We picked it back up in earnest in 2018 with some new engineers and have been working on it in conjunction with the next generation infrastructure network. Anyway, this is NANOG, of course, so they said I have to talk about the network maps and the big numbers before I get into the really interesting stuff, which is, of course, the security stuff. As part of our fiber network upgrade, we replaced the underlying fiber leases in about 80% of our footprint, which means we are now capable of 800 gig plus wavelengths and 32 terabits per second capacity per link. The packet network upgrade means we now have at least 24 400 gig ports and 12 100 gig ports in every node. And our intra-node capacity is now a minimum of 2 by 400 gig. Almost all of our three-way sites have an exit capacity of 2.4 terabits per second minimum, and some have an exit capacity of 3.2 terabits per second. We want to take a look back at 2010, which was when we installed our previous network. In 2010, our backbone link capacity was 250 gigabits per second total. And our upgraded next generation network now is capable of 127,700 gigabits per second. In 2010, our total device capacity was 453 gigabits per second, and our new upgraded total device capacity is 810,000 gigabits per second. Over the same time period, our total annual traffic has increased from 104 petabytes in 2010 to 2,800 petabytes in 2021. It's a nice network we built here. It sure would be a shame if something were to happen to it. Our previous network was running on the Juniper MX platform, and we subsisted on a diet of access control lists and control plane policing via firewall filters. We used the counters to track hits via SNMP. We had a few thresholds that we had chosen mainly with a dartboard, and some of them had been removed over the years when they proved prohibitive. In addition to stateful filtering, we also wanted to filter outbound traffic, which was something that we were not already doing. In the new next generation network, control plane policing is done with Cisco's LPTS, Local Packet Transport Services functionality, which is supposed to act like an intrusion prevention system within your router. The secure management network is a separate layer of protection on top of that. Our existing management network was really nothing groundbreaking. Older Cisco devices configured for reverse telnet with some terminal servers patched in. The sort of thing that you would really hope you could find documentation for when they woke you up at 2 a.m., basically. Given the chance to fix something, you'd want to make it more friendly in a network emergency. Given the opportunity to rethink this, we took it. The first thing we had to look at was what should go through the secure management network and what shouldn't. Obviously, Secure Shell should go through the secure path. We have performance monitoring servers at each location. We can manage them via their out-of-band iDirect ports that should go via the secure path too. And anything else read-write, like we use a lot of netconf, that should go via the secure path as well. Low-impact stuff like SNMP is probably fine. If you step back, though, in the case of an emergency, the goal is to restore network access. So anything that's required to achieve that goal should go out of band over the secure management network. Things that should go in band instead are bandwidth-intensive things like software upgrades and NetFlow. Additionally, we've identified a bug that we have filed with our vendor because RPKI route origin validation can only happen via an in-band loopback. We hope to have that resolved soon. Lest you thought any bit of this would be easy, our homegrown tools assumed only one primary management IP address, and they had to be redesigned to account for the primary out-of-band path as well as the backup in-band path, in case the secure management goes down. We have to have contingencies for our contingencies. The secure management network has three essential parts: the dedicated router, firewall, and terminal server. And we have those across three different site types. The biggest change for us is the hardware firewall. You may have noticed that we're proud of the speed of our new network. In firewalls, well, Nanog's held in Austin this year, right? You don't bring a Toyota Corolla to the Formula One race at Circuit of the Americas, do you? Wait, someone is telling me in chat right now that they in fact have brought their Toyota Corolla to a track day at Circuit of the Americas. Congratulations. Very good job. Now, we don't have a lot of experience having firewalls in our production network, and it's been a bit of a sea change. I'll touch on that later. Given the chance to greenfield a new secure management network, we mapped out three different site types. We have an entry-exit site, a standard site, and a remote site. They're all slightly different, so I'll explain how and why. You'll notice that each different site type has a dedicated router for the secure management network. The router has three different VRFs, one for optical management, one for a performance monitoring server management, and one that serves as the primary path for managing the network and any other devices required for the network to function, such as our PDUs. Traffic between the VRFs has to go through the big firewall, which in this case is a Juniper SRX 1500, and that is where the Firewall Rules live. Now, this is an entry-exit site for us, which is why we have the big firewall here and a slightly more complex network topology. First up, we have the 100 megabits per second wayside channel optical service channel over the optical network. Of course, 100 megabits per second isn't a whole lot. And you know, us security people tend to be a little bit of an anxious bunch, so we couldn't rely solely on that. In comes the layer 3 backbone over the new next generation network and the layer 2 overlay over that, which goes between the secure management network routers. The big firewall has IPsec tunnels to the wee firewalls at some of the other sites. And finally, as displayed in purple, at most of our secure management network sites, we have some 10 gig optical circuits for good measure. Again, this is an entry-exit site. We have 3 active entry-exit sites up, with 2 more planned. They were chosen for their geographic diversity and physical proximity to our partners at Indiana Gigapop and Lumen. The standard sites are very sad and disappointed and lonely sites because, unfortunately, they don't have firewalls. They have all of the other links, the 100 megabits per second wayside channel optical service channel, the layer 3 backbone, the layer 2 overlay, and the 10 gig connection, but no firewall. This is a remote site, which means it has a router, but it does not have an optical node. It also has a wee firewall, which is a Juniper SRX 345. I'll pop the links up, but I think you get the picture by now. Our secure management network is good enough, smart enough, and doggone it, people like it. So we monitor it just like we do its older sibling. 2 walks a day, homemade food, who's a good network, the whole 9 yards. We've had a homegrown configuration management tool that we've used over a number of platforms over a number of years, where our next generation infrastructure network is using Cisco's Network Services Orchestrator for automation, standardization, and policy management. We are working on migrating the secure management network configurations over to NSO and hope to have that completed soon. Now, I don't know if any of you have been in the position of creating a whole new firewall rule set where none existed before. If so, my condolences. We had a couple of access lists that were created back in the dark ages. I should specify that I mean like 2010 thereabouts, not the last 2 years. Our optical management platform was changing. Our partner networks were changing. So which rules did we need and which rules could be discarded? What did the manufacturers say their required ports were? And what were they really? Did anyone really know? We knew some things, but not everything. So we bit the bullet and did the only reasonable thing. We ran away and cried. No. Then we looked at the old ACLs and used those as a basis for creating a bunch of rules. We did add a permit and log at the end as a catch-all because we didn't want to block required traffic. Since the Juniper firewall logs include the name of the firewall rule that's hit, this allows us to look at what's being permitted by each rule to ensure that the rules were working as intended. It also allowed us to look at what was being caught by the permit and log at the end so that we could go back and see what was being permitted that we didn't know about. We established Slack channels with the stakeholders for each zone type and used those to help us create new rules with the goal of removing the permit and log entirely. It also helped us identify a few misconfigurations. When the performance monitoring servers, for example, were using a legitimate but not previously accepted by us NTP server, that it helped us to work with the management team for the performance monitoring servers to resolve the problem in a way that was easiest for them. In this case, it was for them to push out the correct NTP settings to those servers themselves, so we didn't even have to make a firewall change. If it had been easier to make a firewall change, that's something that we would have run through our normal change management process. That's not to say it's all been sunshine and roses. There may be a rule whose name contains shh, which is meant to just silence the one host who refuses to change its syslog settings, so it stops filling out my logs. Eventually, we got rid of the permit and log rules, and no engineers were harmed in the process. That's what they told me I had to say. We finally did the boring grown-up security thing and created some policies governing creation, modification, and removal of rules. We have a specific workflow where new rules must be requested and documented so they can be reviewed on a regular basis. And of course, all changes have to go through change management. So I have a couple of templates created for my team to make common things like address book changes easier. I have a little bit of extra time, it looks like, so I'd like to go a little more in-depth into the firewall rules that we've created and what we've learned from them. Work, 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 work. I'm kidding. I told you there'd be more Sesame Street. Fun fact, before this presentation, I had not noticed that the Swedish chef has human hands. True story. You're saying it now. I know. You're welcome. Of course, we have a few next steps. We have an ongoing review process to determine if any rules can be removed or combined. And we have monitoring in place to check on unexpected changes in permitted or denied traffic. We've created workflows around verifying firewall address books based on our internal source of truth, and we'll be creating workflows to audit the configuration once we move to NSO. I need to clean up some broader SSH rules and remove some redundant rules, so those two things are on my to-do list. For instance, we have a global rule that's permitting radius, which is processed after all the zone-specific rules. So we don't really need a radius rule for each zone, do we? My coworker has been working with an open source firewall documentation tool, which will make it easier to parse the configurations so that I don't need to go back and make those changes manually in our documentation after the fact. Shoot, I totally forgot that I meant to do that. Could one of you guys remind me? Thanks. Additionally, we want to enhance our firewall reporting by finding rules that aren't being used and can be removed, which kind of begs the question, can you Splunk that which doesn't exist? We had quite a bit of fun, each trying our hands at various vulnerability assessment tools against our new devices from points inside and outside the secure management network. We have a commercial product as our primary means of assessment, but we wanted to see if we could find any interesting tools for our purposes. My coworker tried some things that he found on GitHub, and I ran through some Kali Linux tools. We documented our findings so that they can be repeated in the future as needed, say, after we do a software upgrade and need to reassess. We also really want to simulate a full site outage to verify that failover works as it should for the secure management network and for our internal tools at some of those sites. And of course, training our other engineers on basic firewall tasks. After all, you can lead a network engineer to water, but we also need to make her secure it. The easiest solution can be nice when you're running a network, but it's probably not ideal for a firewall configuration. Thank you for coming to my my now presentation. I'll be happy to take any questions, and hopefully my coworker has been answering some in chat as well. Thank you.
Hi, Adair.
Hello.
All right, we do have some questions in the chat for you. So we will start with Blake Willis. He says, great talk, thanks. Are you using Juniper SRX's new VRF groups to run L3 VPN VRFs on your firewalls in flow mode?
No, we are pretty much just doing things as simply as possible, basic firewall zones.
Thank you. Matthew Pitek asks, Adair, your architecture seems to rely entirely upon the optical network being present and available in order to work for both your in-band and out-of-band 100 megabit OSC channel. If the optical platform completely dies, do you have dial-up or other, oh shit, access path into your sites?
Finger language. Gosh.
I didn't write it.
We're working on external commodity connections at our entry-exit sites.
Great. And then George Amodio asked, what open source tool?
It's called SRX Audit Tool. It's from GitHub.
Cool. Any of you guys have questions here? I think that's all we may have for you then. Well, thank you so much, Adair. That was a lovely talk. Thank you for your time and for joining us live for question and answer. Let's give Adair another hand.